Now some atoms get together and they like to share. Two nuclei mutually attract an electron pair. This holds the two together, and in terms of chemistry, we like to say they're bonded covalently.
This is episode 601, and we are going to talk about how we name covalent compounds. And so what you're going to need is your set of notes, and you will also need your naming compounds flow chart. For this episode, we're really only talking about this part right here. We're just doing molecular. We'll do ionic and acids a little bit later, so we'll split them up. Maybe they won't be too confusing. In your notes, first thing we need to talk about is just remember we have used some chemical formulas before, something like H2O, or in biology you had C6H12O6. And so what does that really tell you? Well, that's the chemical formula, and that tells you the relative number of atoms of each element in a compound. And for molecular compounds, we're talking about covalent bonding, which is what this episode is going to concentrate on. And for a covalent compound, the formula represents the number of atoms of each element in a single molecule. When we're talking about covalent compounds, we call those molecules. Now, for ionic bonding, we're talking about metals and nonmetals bonding together, and we call this the formula unit. Actually, we don't really call this a molecule. So this is the simplest ratio of positive and negative ions in one formula unit. Now, the difference between these two, this has to be in the lowest ratio. So this would have to be like a 1:2 or a 2:3. For ionic, you could not have a ratio that was, say, 2:4, because that would reduce down to this. Now, up here in molecular, when we have a molecular compound, we actually do have ratios like this one over here. This is really, in lowest terms, this would be a 1:2:1. But when we're talking about molecules, we actually put them as they really are. We don't put them in the lowest term because of the way they bond. And we'll talk about that some more in a little bit. Okay, so for an ionic bond, just to refresh your memory on that, this is the attraction that binds oppositely charged ions together. And for metals, they give away electrons, and they are positively charged. Let's just put a plus. Positively charged, and we call those cations, not cations, but cations. For nonmetals, these are going to gain electrons, and they are negatively charged, and we call these anions. We would need a metal plus a nonmetal, and so we would have positive, negative. We look these oxidation numbers up off of the chart, and that's what an ionic bond looks like. For this episode, though, we're going to concentrate more on covalent, so let's look at molecular. All right, for molecular compounds, at the top of your notes, that statement, it's basically the exact same as this, so you don't have to fill that in again. It is the exact same, just I accidentally cut that out and put it right back on there. But when we're talking about covalently bonded atoms, we are talking about nonmetals. Okay, so you need to make a note of that. Nonmetals only. And we use a prefix system for the nomenclature. Nomenclature means naming system. And so the prefix that we actually use for this, some of them you may already know. We're going to go up to 10. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you've probably heard of the prefix for 8, which is octa. And in gasoline you have octane, which means it has 8 carbons in it. And then we have hepta, means 7. Hexa means 6. Nona is 9. Deca is 10. And then over here we have mono, di, tri, tetra, and penta. Oops. Okay, so these are the things that we're going to use to actually name the compounds, only if it's a covalent compound. And that's really the only place where you are going to get confused on this, is you have to know which ones are covalent compounds and which ones are ionic. Because once you know that, the rules are 100% there all the time, and they're really easy to follow. So let's look at an example. If I had 3 nitrogens, I would call that trinitrogen. Okay, so you're just going to put this prefix right in front of the name. Now let's look at what actually happens with some examples of your compounds. We have, on your paper, you have dinitrogen monoxide. All right, so first thing we're going to look at is dinitrogen, which would be how many nitrogens? 2. And monoxide, so we're going to put the symbol for O, and there's only one of them. You don't put the number 1. Okay, ones are understood. If there wasn't one there, you wouldn't have the symbol. Look at the next one, tetraphosphorus decoxide. So tetraphosphorus, tetra means 4, so you're going to put the symbol for phosphorus and put a subscript 4. And then decoxide, you're going to put your oxygen and you're going to put a 10 down here. Now this is not lowest terms. If this was lowest terms, we would reduce this down to 2 to 5, but we don't do that in covalent compounds. Okay, they don't have to be reduced down. Okay, we have carbon dioxide, which would be carbon 1, since there's no prefix, and dioxide is an O with a 2. All right, now why did we not put a mono in front of that? The only time you use a mono for anything is on oxygen, and if it's the second element. If it's the first element and there's only one of them, you don't ever put a 1 on there. You don't put the mono. And then carbon monoxide would be 1 carbon and 1 oxygen. So you wouldn't say carbon oxide, you would say carbon monoxide because there's 1 of them. So that you can take any name of a compound if it uses the prefixes, and you can write the formula. Very, very easy to do. So what are the rules for actually naming those? Well, for molecular compounds, when we're naming them, okay, the elements are named in the order in which they appear in the formula. Okay, they appear in the order in which they appear in the formula. And the prefixes are used to denote the number of atoms of each element in the molecule. So an exception is that the first element given is only given a prefix if there's more than one. Only given a prefix if there's more than one atom in the formula or in the molecule. Okay. In the prefixes like nona and deca and hepta and penta, the O or the A at the end of a prefix the O or the A at the end of a prefix is dropped. We just drop it off when the word following the prefix starts with a vowel. So if you think about oxygen starts with an O, so we would drop off the O or the A. Okay, and then the second, this is really, really important. Your second element, the ending is always changed to IDE. So if your last element is oxygen, you would write oxide. If it was nitrogen, you would write nitride. Phosphorus, you would write phosphide. So let's look at a couple of examples. We have ICl3. Okay, I would be iodine, so we just name that. There's only one of them, so we don't put the prefix. Now, we have 3 chlorines, so we need to put the prefix for it. So you go back and you look at your prefix list. 3 is tri. So it would be iodine and then tri. Now, chlorine, the root word is chlor, so we would do chlor and then put an IDE on the end of it. And then the next one would be AS2O5. Look at your periodic table and see if you can figure out what that one is real quick. So AS2O5, when you look up on the periodic table, arsenic is AS, so this would be diarsenic. And then 5 oxygens would be penta. We drop the A and do pentoxide. So for each one of these, you should be able to look at the prefixes. If you're given the name, look at the prefix and write the formula from it. If you're given the formula, use the numbers to look up the prefix. And then just make sure that you follow these rules for it. So we'll go over some more of those in class, but try a couple more. On your packet, if you'll look on page, let me look at the page numbers real quick. Try some of them on page 11. So page 11, go ahead and try like 1 through 5 on the top and 1 through 5 on the bottom and see how you do on those. Okay, and then we'll talk about those in class and see how you did on them.
What's going on? How do atoms form a bond? Why do they stick together? How do they hold on? How do